Hi learners, now we'll understand about writing a program to generate a square waveform using 8051. Okay, so we have studied about 8051 in 4th unit, about its internal architecture, addressing mode, instruction set, everything. Now we'll understand how to make a square wave, how to generate a square wave. Generally, the square wave will have x and x-axis for on pulse and off pulse will be same, a small change. Okay, so the x-axis value for on pulse, off pulse will be same, so it's like a square structure, so it's not so exact. So okay, imagine it is a proper square structure, right? So how to generate it? First of all, we need to connect the DAC with 8051. So I am just connecting 8051 with DAC. So which port we can choose? Any port we can choose, our wish. So I am choosing port 1 here. The program I have taken port 1 for port 1 first. Okay, so that's fine. So here is the output we are going to get as square wave like this. Okay, so how to generate it? So these two are amplitude, right? The top portion is the high amplitude, this one is the bottom one is the lower amplitude. So okay, so port 1 is selected. So port 1 is output port or input port? It is obviously an output port. So here 0 0, that's why we are sending 0 0, because 0 means output, 1 means input. So 0 0 is sent to port 1, so that the port 1 becomes output port. Next, we need to have a count, so we can make it as an indefinite waveform, that's a continuous waveform, so that we can put it in indefinite loop. But still, so here in the program I have just taken, so I am just I am just going to create 100 pulses. 64 hexadecimal is actually 100, so 100 pulses, say here. So that is why one register I have chosen, that is R0 register, and in the R0 register marker, yes, the R0 register is initialized to 0 because it needs to be incremented up to 64 hexadecimal, that is 100. Next, so first value FF, this one is FF, the first value is sent to port 1. So through port 1 it goes to DAC, then DAC produces output, which one? This first one, FF. Then that it's not the entire thing, FF in the sense this alone. Which one? It's a marker, yes, this alone, this portion alone is FF. This horizontal lines indicates delay. So the first peak indicates the amplitude FF created by DAC, digital to analog converter. We have sent only FF, so the first portion, so not this, yes, so here not this, ignore this. So this one is the first one, say first pulse, then second like that, third, imagine like that. So here the first one is FF, so the remaining, this horizontal line is delay. So we have to call delay program I have explained in the previous video. So again I will tell, we call delay. So FF is sent, and then we called delay, and then we are sending 0 0 to the same port. So 0 0, which means here say FF is sent, next delay, then next 0, then next delay, then next FF, then delay 0, then next delay FF, delay 0. It goes on till 100 pulse, that is 64 hexadecimal value. Okay, so that is what is increment R0. We are incrementing R0, okay, for every on and off pulse. So these two, on pulse and off pulse. This one box, okay, is one because FF this one, 0 0 this one, okay, on pulse off pulse. So 100 pulses we are generating. Compare and jump not equal to 64. The R naught not equal to 64. So R naught should become 64. If not, again do the same thing from here to here. Send again FF, send again 0 0 100 times. Once 100 times is reached, then terminate the program. So this is, there is no halt instruction 8051. That's why HJMP short jump here, the same address we are writing. So we will press reset and come out in the trainer kit. Yeah, this is how we generate square waveform. And delay, as you know, so any amount of this, ignore this, this is for practical purposes. Fine. So here FF alone, or you can just simply give, say, an example 69. Okay, it's not 69, it's 69 hexadecimal. Okay, so 69 hexadecimal. This value we can place so that the square wave pulse changes. Sorry, the amplitude change. Sorry, it is delay, right? So here 69, if you put, say, the x-axis value previously like this, FF, say an example, this is for the value of FF, okay, full count. Then next I am reducing into 69, the next program. So this becomes like this. I am changing the x-axis value. This is for the 69, okay. Yeah, so this is what is making square waveform. This is how we can make square waveform. This is very simple. Whenever we we use call instruction, obviously in the subroutine we must write return, so that the value stored in the stack, the address, okay, will be retrieved and it will go back to the next instruction. So this is how the square waveform works. Okay, thank you. Hope you have understood.